Okay, hello everyone. So today I'll be talking about how to use torpedoes in War Thunder. So in order for you to really understand how torpedoes work, you have to understand some stuff, some math like trigonometry, and especially the law of sines, which is right here. So sine of A, angle A is divided by A. Here, sine of B, sine angle B is divided by B, like that. Sine C is divided by C, and that's how it works. So basically, it works for a triangle with not a right triangle, but any kind of triangle, basically. So there's different scenarios for it. So if your ship is moving at a parallel direction to your target or enemy ship, you do have to get some stuff like the velocity of the ship. You could kind of like estimate that based on well, there's a way of getting the velocity of a ship. So it's called the distance divided by the time. So that's how you get it. So let's say a car or something, or my walking speed, let's say I do about I could walk about 10 meters. I mean, maybe 10 feet per second or something. See, that's what I could do. That's the rate, let's say. The 10 feet per second is how many miles is that per hour or something. Ten feet per second times 60 seconds times 60 minutes divided by 5,280. That's about 6.81 miles an hour. So just by getting the rate, rate of change per time, you could get the velocity per hour or speed per hour. So you would get the speed of the target ship. Let's see, that's 75 kilometers an hour. And my torpedo is moving at 91 kilometers an hour. And this part is the hypotenuse right here. That's where I'm launching the torpedo at this launch angle, But we can't find the launch angle until we find the deflection angle, which is right here. And we would we would use the law of sines to figure that out. So we know what the target speed is, right? So that corresponds with the deflection angle. So 75 is divided by sine of angle D, which I put right here, is equal to 91 kilometers an hour. And this angle is 90 degrees. It's a right angle. So I would put sine 91 degrees divided by sine of 90 degrees is equal to 75 divided by sine of D, which is right there. That's what I want to find or solve for. So you just get your calculator out, make sure you switch it to scientific. I'm going to use degrees, not radians, so degrees like that. So let's solve it. So basically 75 times sine of 90 degrees divided by 91, and we move this here to that side. So this is how it is. So sine of 90 degrees is what? I think it's 1. Okay, that's 1. So 75 divided by 91 is 0.824. And then we have to get the inverse sine of that, which is right there. So the inverse sine, go here, inverse sine is 55.5 degrees, or 48 I put there. And this angle right here is 55.5 degrees, right? And the angle of this is 90 degrees from here to there. So we need to find a launch angle. So 90 degrees minus 55.5. So 34.5 degrees is a launch angle to hit the target. So basically, as you can notice, as you see here, my torpedo speed is much faster than the target ship. So the target is slower than the torpedo. So the angle would be a little bit steeper compared to, let's say the ship was moving at 91 kilometers and my torpedo was moving at 40 kilometers. Then the angle, launch angle, would be less, right? It would be maybe it would be less than 55.5. Probably it would have maybe 13 degrees or something, or 14, because it would have to travel further to hit that target, which is moving faster than you. So this is how the triangle would look like. So slow target, fast torpedo, angle is steeper, right? Fast target. So basically, fast target, slow torpedo. The angle would be, launch angle would be less than, right? Because this is more, this is less. So that's how you would kind of get a conceptual view of this. So if the theta slow target is greater than theta fast target, so the angle of a slow target is greater like that than the angle of a fast target, which would be less. So that's basically it for that. So that's how you would conceptualize it. Okay, the next slide is basically shows what happens when the ships are moving in opposite directions to each other. So we would have to use something a little bit more different. So we could still use the law of sines to solve for it, basically. So let's say I know the angle from here, from my ship to the enemy ship, and what I do is I form a right triangle, a right angle, and let's say that is 35 degrees, right? So basically, theta B should be equal to theta A, and that's 35 degrees, but you could prove that easily. So this is 90 degrees right here. We know what this is, so we should be able to find that, because the sum angle of a triangle is 180 degrees. So that's 180 degrees minus 90 degrees minus 35 degrees. So that's 55 degrees right here. So 90 degrees minus 55 degrees is 35 degrees. So theta A is 35 degrees. So we use the law of triangles to solve for, so we know what 30. We know what theta A is. So theta A is corresponds to the torpedo speed. Okay. So theta A divided by 91 kilometers an hour, and we're trying to solve for theta B here, so we could find the launch angle, basically. Theta B corresponds to this 75, the target speed, target ship speed, 75 kilometers an hour. So sine of theta A, 35 degrees, divided by 91 kilometers an hour. Okay? And theta B, this is what we're trying to solve for, is divided by 75 kilometers an hour. So sine of theta B, we just move this here, leave that there. So sine of theta B is equal to 75 kilometers an hour, sine 35 degrees divided by 91. So let's get our scientific calculators out. Just go to scientific calculator, or if you have a scientific physical one, you could just use that. So sine of 35 degrees is 0.573 times 75 divided by 91. So that's 0.4727. So we solve for the inverse sine of that. So this is the number that we got. We use inverse sine to solve for this. So that's 28.2 degrees for theta B, which is right here. So theta D is here, right? So we're trying to find the angle of theta. So notice how this triangle does not look like this one. It's more like this, isn't it? Right? So our launch angle is all of that. So from here to here. So the sum angle from here to here is 180 degrees. So 180 degrees minus theta B plus theta D. So I'm going to solve that. So I'll call it theta D, theta L. Theta L is equal to 180 degrees minus theta B plus theta D. 180 minus theta D, which I said earlier is 35 degrees. Theta B is what we just solved for, which is 28.2 minus 28.2. So, of course, this is 90 degrees here. So we need to get the angle from here to here. So that's 116.8 degrees, which we have to aim in order to hit that target. Instead of, if it was just stationary, we just aim straight at it. We don't have to compensate for any angles or anything. So there's another way to solve it. But using the 180 is definitely a lot easier. We could say theta, we can have theta E also. So we call this, let's say, theta F. So 90 degrees. So if we want to solve for theta E, we could do that. So that's 90 degrees here minus theta B plus theta D. So theta B 28.2, theta D is 35 degrees. Minus 90. So we get 26.8 for this part. And we know what the angle of this is. This is a right angle, so 90 degrees. So we get the same thing. Except I think using the 180 is definitely a lot easier. So we could use it both ways. So anyways, as for the triangles and how they look. So this is a general concept. If your torpedo is faster than the target, then you're going to get a triangle that looks like this. Right? This is a case. So if the torpedo is slower than the target, so if this torpedo is only 45 kilometers an hour and the ship is moving, let's say at 100 kilometers an hour, then the triangle, then your launch angle would be less. It could be 55 degrees or something, or whatever. It could be 25 if it was really slow. Then this angle would be more right, covering more distance, because this is moving faster. So that's basically it for that. So now let's play a few games and see how. Okay, so now let's play I'm going to first play a test mission. That's what I'm going to do. I'm going to demonstrate just generally how you could use torpedoes. So these targets right there are capital ships are not moving. You see these ships? They're just stationary. So I'm going to launch some torpedoes at them.
The enemy ship sank.
Okay, and I'm moving at about, I guess around 70 kilometers an hour. And I don't have to compensate because these ships are not moving. So I launch 1, 2, and 3. I want to see the distance of that. Is 4.72 kilometers from where I am. So it should take about, let's see, 4.72 divided by 91 kilometers. So it should take about 3 minutes and 7 seconds or 6.6 seconds to get to that target right here. And for this one, it's about 6.7 kilometers away.
Torpedo impact.
About 4 minutes. That one was a hit. I didn't have to compensate or anything, because it's not moving. See? Second one got hit. I didn't have to compensate at all because it's stationary. Let's see where the third ship is. That ship was about 8 kilometers away. The speed of this torpedo I launched is 25.2 meters per second. That's 91 kilometers. Okay, but anyways, it got hit. So these ships were stationary, so we didn't have to compensate. So let's play the next. Okay, so I'm gonna be torping a little bit. So this is not the ideal map for using a torpedo ship, but I guess if I can get to the other side, then I could use my torpedoes, which I will be doing. So he's turning again. So I guess what I launched isn't going to hit it. So I guess I'll just launch here too, just in case. Fire both directions. Okay, there's the enemy carriers.
Threat in the air.
I think they're stationary targets, so I should be able to hit them.
Gunners are searching for airborne and surface targets.
If we don't do something fast, the enemy will win.
Because now I'll have the guns to do some damage. Or the guns on that destroyer that hardly did any damage, but these guns can do something. Looks like I torqued somebody. Very lucky.
Attacking A-points!
Dodging torpedoes isn't very hard, especially when your ship is faster than the torpedo that was launched against you. Uh-oh, a destroyer. Let's take out those carriers now. There's a little PT boat there. These things are a threat. Little bastard. I'm gonna sink that guy. Very difficult to hit. They're so fast. Sank a ship. Not a base this time. Anyways, let's launch more torpedoes at these ships.
No! We lost. But next time, victory will be ours.
Yeah, torpedoing it isn't very easy to do. There's no ship in combat is going to stay in one place, nor are they going to stay the same course when you're attacking them. That's the difficult part of it. But anyways, I basically explained the basics of torpedoing, and I hope you got something out of it. Okay, so thanks for watching my Ace 1000 KS.